Welcome to this week's paper reading here at Arise. While folks kind of come into the room, we might start with some introductions. So my name is Dat. I'm a solutions architect here at Arise. I build a lot with our customers. I brought some very special guests with us here today. Sally Ann, if you want to introduce yourself.
Yeah. Hey everyone, I'm Sally Ann. I'm a product manager here at Arise. I work on a lot of our products, but most recently I worked on our Copilot feature. If you haven't checked it out, definitely go do that. And then we also have Cyrus with us. Cyrus, you want to do an intro?
Hey everybody, I'm Cyrus. I am a core contributor at DSPy, and with another one of the core contributors who's a good friend of mine, we started a startup called Zenbase to commercialize its technology.
Awesome, thanks. And so yeah, the reason I brought Sally Ann and Cyrus is because I don't really know much about DSPy, so I thought I'd bring them on here to educate our audience and our users on DSPy and why it's so amazing. We did get a chance to I did get a chance to listen to Omar Khattab's talk recently here in San Francisco. Amazing talk. So thought it'd be great to bring one of the heavy hitters. So to get us started, I think for the agenda today. We're really just going to do an intro into DSPy. I think for a lot of folks, like maybe myself and others who've never really heard of it or used it, you kind of really want to understand like why do people like it? Why is it, how is it so different from maybe some of the other frameworks? We'll go into things like assertions inside of DSPy, so some of the moving parts. Really kind of what makes DSPy unique is maybe its optimizers, which Cyrus and Sally Ann will go into depth. And then we actually have a coded up example at the end that we'll walk through too, just to give people really a feel and the intuition for the framework. And really to get us started, maybe I just want to talk a little bit about my journey, kind of trying to understand the framework. And if I had to really describe DSPy in a nutshell, and I could be completely wrong here, so Cyrus, Sally can correct me.
You're gonna do a
Um,
great job, Dad.
the way I described it is like you're really telling DSPy not how to do something, but like what you want. And it's like very different than how we do prompt engineering today. So Sally Ann will go into the motivation, but I think if I had to break it down, it's like step one, you really define what you want it to do. So in DSPy, I think they're called signatures. This is like the shorthand for signatures. It's like you basically describe three things. It's like what's the input of this particular you can think task or thing you want it to do, what's the output kind of look like, and then maybe a small description. So it's basically, hey, what's the task you need it to do? And then maybe step two is like you collect a very small amount of examples of what that looks like. What are good versions of, input, output, and kind of examples from your real world of the task that maybe you want it to look like. Three, and then you construct, and this is the part I don't know super well, but you construct your pipeline using modules or DSPy layers. And it's really kind of like building a pipeline to get the thing that you want. I think we'll go into depth on that later. And then four, finally, DSPy really, or DSPy optimizes your prompt and generates kind of your final text from all kind of the examples and your pipeline. For me, I guess I think running the minimal viable example in Colab was really a great place to start. So we'll post the GitHub link in kind of the chat here. And then, to be very honest, while looking at the paper, it was a little dense for me really to get a feel for what's happening. Maybe I'm more of like I kind of have to do something to understand it. I really thought the docs were really great to kind of get started. So that minimal kind of working example was kind of here in the quick start. So just as a heads up for me, that was a really great way kind of to get started here. And so next, we'll go on to kind of the motivation, but just wanted to give a quick like DSPy in a nutshell.
Can I jump in on the nutshell part
Yeah.
to give a high level like if you are coming from an ML background and you're used to something like PyTorch or TensorFlow, where you create modules, you say how you're going to do the math, but when you initialize it, it's got all these random weights. And DSPy is kind of like that. You create these modules, you create your transformations. Initially, there's these basic prompts. And just like you would in PyTorch with an optimizer like Atom or SGDR, DSPy has its own optimizers that will go through and optimize the prompts to minimize your loss, or rather, DSPy calls it maximize your metric in your training set. So point number two you can think of as your training set. There's a testing set too. And like Dad said, the whole goal here is to be more explicit about what you want and not have to worry about how it's exactly done and let the computer optimize that for you.
Awesome. Yeah, I think going into the motivation and maybe why you should learn DSPy. Yeah, Sally Ann.
Yeah. So DSPy was a great framework, kind of had all those modules that Dat was just describing and Cyrus just describing, but there was kind of this need to control and refine the LLM output. So they created this way so that you didn't need to do all this prompt engineering. You could just use these composable modules and automatic optimizers. That was great, but there was no way to actually control the outputs. So that was kind of the main motivation there. So there are no tools that you could set the specific rules for the LLM behavior. You could kind of just set your intention or what you wanted the LLM output to be. And they also felt that there was a need for help in debugging and improving the responses. So taking the example of the multi-hop question answering data set, if you're not familiar with what that is, essentially it's a data set where it requires the LM or the task to gather information from multiple sources and do this multi-step reasoning. And so even looking at that task there, the task is to do these complex question answering, but there's long and imprecise queries, there's redundant information retrieval, and so these were kind of some of the challenges that the team wanted to use assertions for to kind of overcome. So that's kind of the high level motivation. I don't know, Cyrus, anything else you would add there for that?
Yeah, I would add that like when you have a pipeline of language model calls, there are checks and balances you want to have at different stages. And currently, I mean, before this paper, you would have to run through the whole pipeline and then get to the final result at the end. And you couldn't really implement those checks and balances in between, and let alone have those checks and balances optimize the prompt and loop back into what prompt is used to maximize the metric in the pipeline. So, asserts and suggestions let us give hard and soft constraints of sorts to the language model. And this way we can sort of nudge it along in the individual steps of the pipeline.
Yeah, and then one thing I'd like to add too is like for folks who are maybe like used to, if folks on the call have ever done like prompt engineering, right? What you're kind of doing is like you're manually crafting, you're like saying kind of like this is what I want you to do and how to do it. It's probably the most common approach when you think about other frameworks, right? You're just like saying, hey, here's the prompt, go do this. You might chain together some modules, but I think maybe the take is if you've done a lot of this, you kind of notice maybe if you change a model or you mess something up or you have conflicting kind of sentences in your prompts, engineering or maybe sets of prompts, you might see it a little like it doesn't feel as robust. It kind of feels like it would break and it's very fragile. And I really think this like paradigm shift of like, hey, um, what if we made this more robust rather than like, more like less brittle? How do we make this less brittle and more scalable to changes? I think is a really good motivation too for folks who are like, who feel like there needs to be a little bit more engineering rigor around LLMs. So
That's very true. And another analogy I can draw that might help people out is if you think of prompts as assembly and language models as CPUs, then you know that like every type of CPU or different architectures, instruction sets have different assemblies that you have to use to get the maximum performance out of it. And similarly, like one prompt that might work really well for GPT-4T may not work that good for Sonnet 3.5. And so what did we do in programming? There are still people that write assembly, but we now have higher level languages that we code in, and then we have the computer figure out how to execute that on the CPU. DSPy is offering a similar level of abstraction. We, instead of focusing on the prompts themselves and how do you craft the precise best prompt for the specific model that you're running it on, you let the DSPy optimizers handle that for you. And you just focus on the high level program logic.
yep, exactly.
We
So
actually have We actually have a good question, I think, in the QA to kind of clarify how DSPy works. So the question here is, asking if this is like some kind of supervised learning where we're taking the input and output. Do you want to add some more color to like what's actually happening in DSPy when we're defining, the what and not the how?
Sure. So this is to Vignesh's question
Hmm.
in the Q&A. And DSPy does support supervised learning if you have the inputs and outputs for your entire pipeline. That works great. But you can also use DSPy without the outputs, so long as the final output passes your metric function, passes a certain threshold in the metric function. Then DSPy will consider that as a successful case, a pass, a pass. So you could use DSPy in both a supervised and an unsupervised sort of way.
Awesome. I'm
Awesome.
going to hand over the sharing over to Cyrus so he can walk us through. We have the expert here. So, folks in the audience, please ask all your questions while you can.
Sweet. So here is a DSPy cookbook on how to use assertions with tweet generation. I'm using this example because a lot of people have seen tweets. It's pretty straightforward. And after doing all the setup here, all the imports, you set up the right things in DSPy, and you set up your data set, your train set, and your dev set. So let's look at what it's like to create a basic pipeline in DSPy. Here we have a tweet generator. So we've got our first signature that says, okay, look, if you have a context and a question, we want to generate a query. This is an output field. So you have the input fields, and then you have the output field. You also have a generate tweet that says, okay, I've got a question and I've got the context that may have relevant facts, and now I want you to generate the tweet. So there you go. And then we create a little module that has this generate tweet attribute. And in the forward method, it's kind of similar to how you might in PyTorch, we have some logic. And in this logic, it's going to go ahead and generate some search queries over here, then retrieve relevant passages. So this is kind of like a RAG setup. And then it's going to deduplicate things over here. Then it's going to go ahead and generate a tweet based on the context that it looked up, as well as the original question that came in. Now, how would you go ahead and like evaluate something like this? Well, you might want to make sure that it has no hashtags. It's within the length limit. If there's this assessment like LLM as judge over here, you want to make sure it says yes, and whether the correct answer has also been mentioned. There's some other metrics here. So metrics are numbers, and DSPy is trying to maximize the metrics. So here, sometimes we're going to go ahead and convert Booleans to integers just to make our life easier. So some more metrics here within the length. There you go. And there's this overall metric. So DSPy optimizes one overall metric for the whole pipeline. And the way you can handle compound metrics, in this case, we have a bunch of things we wanted to check, is you can turn them into integers and sum them, and then maybe divide by 5 because there's 5 of them. So you can do something like that. This way, if it is correct and engaging and faithful, and there are no hashtags, and it's within the length limit, then this is going to be 5. 5 divided by 5 is 1, perfect score. If any of these is false, then the score is going to be lower than 1. So let's take a look at what it's like to have an example and generate a tweet, and it does that over there. Now, what happens with assertions? So the paper that we're looking at today is DSPy with assertions. And assertions let us take some of those metrics that we were checking at the very end of the pipeline and move them into the logic so that as it is generating, as the intermediate steps are running, then we can offer soft and hard nudges, or hard constraints and also soft nudges to the system. So for example, here we have dspy.suggest, which suggests that it should not have hashtags, and you tell the prompt optimizer, hey, please revise the tweet to remove hashtags. Here's another suggestion within the length limit, suggestion having the correct answer. And suggestions are these soft nudges. They won't fail the entire run. They won't fail the entire pipeline, but they just suggest to the prompt optimizer that this is how you ought to adjust your prompt so that you can come out with the right output. And then you can compile it with assertions. So this is a great place to explain what does compilation mean in the context of DSPy. Um, Coming from an ML background, a teleprompter or an optimizer here is your analog to SGDR or Atom, and Bootstrap Fusion with random search is our optimizer here. You can pass it the metric that you're trying to optimize. You have some hyperparams that you can pass through, and then you can compile a student module on the train set and the validation set. So how does something like Bootstrap Fusion with random search work? At a the first thing you need to understand is that language models are in context learners, so that the more examples you give it, the better it's going to perform at the task that you want it to. And so the few-shot family of optimizers are trying to figure out what are the best few-shot examples to include in the prompt. And
Gotcha.
this few-shot,
Real quick, Cyrus, we had a question in the chat.
yeah,
And Raymond asks, is there a reason you aren't asserting the length limit versus suggesting, which is a good question. It might just,
honestly, that's a good question. Honestly, I think it should have this cookbook should be updated to use assert on the length limit.
gotcha.
Nice catch.
And then my question on top of Raymond's is really, uh, where do you like, how do you know where when you should do an assertion versus a suggestion, and what's your thinking around that?
Okay, there was another example here in the there's another example in the DSPy repo where they have both assertions and suggestions, and the example was like RAG with citations, and so there was a suggestion that every 1 to 2 sentences ought to have a citation. That shouldn't be a hard requirement. That's a soft requirement. Make sure, okay, there should be some, citation there. Whereas assertion, in this tweet example, is it can't be longer than 280 characters. It's a very hard constraint. Suggestions are nudges. Assertions are hard constraints that'll fail everything. So depending on the problem you're dealing with, like for example, an assertion could be do not use profanity with the user or something like that. You definitely don't want
Gotcha.
something like that. And then, oh yeah, well, back to few shot with random search. So let's look at Bootstrap few shot with random search. We learned what few shot meant here, which is like how do we find the best examples? And Raymond, I see your question. I will answer it in a moment. And then random search says, okay, we're going to be randomly sampling from the examples that are there and then putting them into the prompt to see, which ones make sense. And then the bootstrap side, what bootstrap means here is it means that maybe you don't initially have the output label. So somebody asked about supervised versus unsupervised learning. Maybe you don't have the initial output labels, and you probably don't have the input and output values of the intermediate steps in your pipeline. And so what Bootstrap will do is it will run your pipeline end to end. And when there is a successful a successful run, it based on your metric, it'll go and save the intermediate input and output values for each of the steps and use those and add those to the set of valid few shot examples for those intermediate steps. And so this bootstrap few shot does a bunch of things. Really, it's trying to, at the high level, figure out the best few shot examples to include at every step of the pipeline. And Raymond, you're asking if there's a way to give a starting prompt to the Bootstrap. There is not. All of like DSPy is, hey, you don't have to worry about it. But if you wanted to include something like that and nudge the LLM in the right direction, then you can, in your signatures over here, as the doc string, you can put a starting prompt of sorts. Like this is where you can put your best knowledge into it so that it's not starting from scratch. And that's it for the example. This was a whirlwind tour of an example. I'm sure there may be questions around this, but would encourage anybody to go into the DSPy docs, check out some of the examples that are around, and if you have any questions, you can hit me up on Twitter or LinkedIn. I'll post my information in the chat for folks. And
Great
then
example. I
Arjun,
think,
oh, go
oh, go
ahead.
ahead. No, I was just gonna say we have a few questions in the docs. I think it would be helpful for us to take maybe a step back, kind of go over the different types of assertions and optimizers, and then maybe we can answer some of these questions that we have in the chat. I'll share my screen real quick here. Go ahead and go on slideshow. All right, so Sarah just walked us through a great example of how to kind of implement with DSPy, use these assertions in your pipeline, but I think it's worthwhile for us just to kind of outline what even an assertion is. So it is a way for you to do this user-defined constraints on those outputs. So you gave the example of like length limits. You can say, only implement with this length, or don't use profanity. Those are all types of assertions. And the goal really here is to enhance the predictability and correctness. I think those are two things that are a little bit hard to kind of get down when you're dealing with these LLMs, just because there's so many variables here that we're dealing with. So this really helps enhance those two things. And you talked about this, Cyrus. There's two types of assertions. So you have these kind of hard assertions. Those are actually the assertions, and these are going to be strict, and they halt the pipeline if repeatedly violated. So once you set your assertion, like for the response length one, the idea here is that we're kind of retrying a certain amount of times, and if it continues to violate the assertion, the pipeline fails. It will not move forward to the next step. I think that's something really important to kind of understand here. And then there's the more soft kind of assertion, the suggestion, where it's like, we're going to guide towards a desired output, but we're not going to fail the pipeline if we repeatedly violate this. So this is just a little excerpt from the paper here. I think the ones that you gave, Cyrus, were great, but I did just want to call out this kind of idea of exactly what an assertion is, and the two types here. Anything that you would add to this, Cyrus?
No, I think you did a great job.
All right, awesome. And then the other thing you talked about were optimizers. And I think these are really cool. And I think we have some questions about these in the chat, but the paper itself calls out these three types. I know there's a variety of other kind of optimizers that DSPy has, but I think these are the ones that are relevant to the assertions. So the first one is the assertion-driven backtracking. And so I think the TLDR here is that it enables retry and self-refinement. So here we're going to use that assert and suggest to retry in this special state. So we're going to process the current error state and the message, and we return this basically new state. And so we'll kind of continue and retry with these updated prompts. We're including the past failure outputs and instructions. And then basically, once that retry limit is met, we're either going to halt for those asserts or move to the next module for suggest. So this is kind of that process we are describing on that last state of whether or not we're going to move forward or not, and we're just kind of using those kind of states to kind of go between based off the type of assertion being used. The second one is assertion driven example bootstrapping. So this is going to be that optimizing the prompt. I think this was what you were using in your example, Cyrus. Is that correct there? This is the middle one? Yeah. Mm-hmm. And so what we're doing here is we have this like teacher-student model approach, which I think is really interesting. And so the teacher model bootstraps examples from the student model, and then we're using that backtracking to ensure the correct intermediate output. So if I'm understanding this correctly, it kind of goes back to that first type of optimization where we're doing the backtrack to make sure we're checking our assertions or suggestion to make sure our outputs are correct. And then that just makes sure that we're meeting those kind of enhanced quality constraints. Last one here, the counterexample bootstrapping. This guides models away from making mistakes. So it's going to collect traces of failed assertions during backtracking and then use those examples as demonstrations. So you kind of think of this almost as like few shot prompting in a way, where we're giving it examples of what not to do actually, rather than examples of what to do. So yeah, I just want to call out these here. I think it's important to kind of understand the differences here. And then, yeah, maybe we could take some questions from the audience. I know there was one about a UI for DSPy. You want to answer that one, Cyrus?
Yeah, there is, as far as I know, there isn't one, but there is somebody named Tom Dewar who is experimenting with one. I've been seeing him tweet about it over the last week, so I would check him out on Twitter and go through his tweets for that, but currently no. Uh,
Yeah.
and then I'm looking at some of the questions in the Q&A.
Okay.
Raymond asked, can DSPy be integrated into agent frameworks like AutoGen? I'm going to send the answer here as well, but TLDR is that DSPy is more around pipelines of LLM function calls and an agentic use case where the agent is deciding the control flow. You could use DSPy for it as well. There are some agents in, like there's a React agent in DSPy, for example. But there's a lot more work to be done on that front. We're actually going to be working with Omar on figuring out how to optimize agents in a more robust way. We've got a kickoff call for that on Saturday. So not, I would say that agents are definitely supported in some capacity, but like a not like a first class robust thing right now. And we are working on that. Now we have, now we have a few more questions that are coming in. Let's see. Is it similar to TextGrad? I'm going to handle this one. Vignesh, I see your question. I will come back to it. Robin asked, is it similar to TextGrad? So for those who may or may not have heard of TextGrad, it is a paper that also came out of Stanford a couple weeks ago. And what TextGrad does is it'll use an LLM to like look at the response and be like, okay, now that you responded this way and maybe this was the score or whatever, LLM, can you suggest, how we might update the original prompt so that it gets better? So you're using the LLM to generate a textual gradient, they call it. And the idea is that like if you have a metric mountainscape, as I like to call it, maybe I can share my screen to show this thing. Oh, all these things, hide all of these, and then this. Okay, can everybody see this?
Yep.
Okay, awesome. This is if you're coming from an ML background, this is a flipped version of a lost landscape. But really, you can imagine there's a search space over here of possible prompts, and these hills represent, the metric you have, and there's a big hill at the top that you're going to have the best result on your metric because you have the best prompt. And this is like a local maxima over here. And so, from my understanding of TextGrad, it might start the prompt somewhere over like here, and then it'll do some hill climbing to eventually get you to here. But if TextGrad starts over here, its hill climbing will get you over here, and then it won't get you over there. DSPy approaches it from a different perspective. DSPy is like, I want to be able to provide some guarantees on finding the global maxima. So with the bootstrap few shot with random search, it's actually going to be testing the whole search space because it's going to be testing, which few shot examples can be used and are the best and in what order. There are more advanced DSPy optimizers that will also do instruction tuning. So the actual there's the instruction you give to the LLM, and then there's the examples. And then DSPy's more advanced optimizers like MiPro V2, they will also tune the instruction in a way that is trying to find these higher parts. But I think it's a deeper dive. MiPro V2, do check it out if you're really curious to dive into the deep end, but it's a bit of a deep rabbit hole for us to get into now. And so similar to TextGrad, DSPy, similar, both trying to be like a PyTorch for LLMs, slightly different approaches to it, and addressing similar challenges. So that's for Robbins. Okay, Vignesh asked, how does the optimize, what gets nudged or guided? It's not doing the individual token probability distribution because some LLM providers give us that, some don't. You can't play too much with OpenAI's LLM probability distribution, but you can, if I'm correct, I think it's the assertions one is about actually like modifying the prompt. So it's going through a discrete search space of prompts with that little example that I was showing earlier, and it's testing out all those different candidates on your behalf, and then reporting back to you which one is the best. Anonymous attendee. How is DSPy different from LLM compiler? Okay, I'm opening up LLM compiler right now to take a look at it. As it's loading on my internet, I'm going to go over to Brenda's question. Is there any code example with agents and to impose the appropriate choice of agents and proper handshaking agents? Okay, this is a deep question. Great question, Brenda. Um, you're also hinting at multi-agent systems here, and there is an example of DSPy where you sort of do a mixture of agents. Like you have some question come in, you have like 5 agents, answered, and then you have one step at the end that synthesizes everything. So you can do that, but in that flow, uh, the agents like are guaranteed to terminate at some point. Um, they're not like very open-ended. In terms of imposing the appropriate choice, I think you can do that actually. Like you could create a DSPy signature that says, okay, like which agent do I route this to? And then route to that agent. And then that agent being like a DSPy React agent can like handle that task. And using DSPy optimizers, it would go and actually optimize the prompt on both of those modules and all the other agents as well, and any other modules you may have in that system. So I think that that is a really interesting question, and I think you should be able to do some of that with DSPy. Brenda's second question is, does DSPy, can it be used with LoRa fine tuning? Yes. So DSPy has a series of optimizers. One of those optimizers is a fine tuner. I don't think it's doing LoRa fine tunes at the moment, but there's really no reason why there couldn't be a DSPy LoRa fine tuning optimizer that would go and do fine tuning for you. Like you noted, and actually an extension of your question, Brenda, is like, there are so many different ways that we can guide LLMs. There's the prompt, there's fine tuning. There's also now some interesting work being done on control vectors. And the promise of DSPy is that as the developer or as the scientist or as the engineer, you can write your program without defining how it gets optimized, and then later bring in an optimizer and we can figure that out for you. So you could, one day have a control vector optimizer. You could have you have a fine tune optimizer today. You have Bootstrap Few Shot. You have MePro V2. You have all these optimizers that you can use for your problem. And then now I'm going to go back to LLM compiler. So now I am quite literally just looking at the GitHub README. I have come
Doing it
across
live.
this paper before. I have come across this paper before. And I think that, okay, so LLM compiler is a bit more like, I'm going to share my screen so people can see this too. LLM compiler is going literally off of this diagram. You have a planner, you have a task fetching unit that figures out presumably like dependencies between tasks and what needs to get executed before what. Now you have this executor, which is like executing the current thing to do, and then these function calling units may interact with some tools. And so I would say that this is sort of like, this is an architecture of a system that uses language models for both this executor piece, maybe this task fetching unit, and definitely the LLM planner. And you could recreate this architecture in DSPy and then optimize the prompts at the various stages of this. So they're not the same. Rather, this is an architecture of a compound AI system, which is a great thing if you want to deal with complex tasks. Compound AI systems are what to do. And DSPy can help you create architectures like this or other ones. And then instead of you focusing on optimizing or like fiddling and prompt engineering, or I call it prompt fiddling the the different prompts in the pipeline. You can have DSPy do something like that for you.
Awesome. Thank you so much. Big shout out to our friend Cyrus for
Thanks for
joining
having
us
me.
on this paper
Really
read.
appreciate you.
He is a great friend and a great person. Sally Ann, thank you so much for joining too on the product side of Rise. Before we hop, I just wanted to give a quick plug. Tomorrow, we've had a lot of releases inside of um, our open source offering called Arise Phoenix. So tomorrow, our developer relations, John Gihuli, and then Jason will also be covering that tomorrow. So quick plug, if you have some time tomorrow, you can see the newest features that have dropped in our open source offering in Rise Phoenix. So thank you so much, everyone. Big shout out to Cyrus and Sally Ann for joining us this week on the paper reading.
Awesome.
Thanks so
Thanks,
much
Zach,
for having
too.
me. Take care, folks.
Bye, everyone.